Welcome to the Explainer. Okay, let's just dive right into this. You know, if you've ever felt like programming is this giant, impenetrable wall of complex math, I'm here to tell you a little secret. It's actually just a series of simple, everyday decisions. Today, we're going to completely demystify foundational Python logic. We'll be using everyday analogies, stuff like light switches and roller coaster guards, to show you exactly how Python actually thinks and makes decisions under the hood. So if you're a beginner, take a deep breath, relax. We are going to conquer this whole thing step by step. Here is our game plan for today. We'll cover 1. Booleans, true or false. 2. Python comparison operators. 3. Making decisions if and else. 4. Advanced logic and or. And finally, 5. The developer journey. All right, starting right off with section 1, Booleans, true or false. So this is the absolute simplest data type in Python. But seriously, don't let that simplicity fool you. It is literally the bedrock of all programming logic. So what exactly is a Boolean? Well, unlike strings of text where you can write, infinite sentences, or integer numbers where you can count into the billions, Booleans are super strict. They can only hold one of two possible states. In Python, those states are true with a capital T and false with a capital F. And that's it. It's exactly this rigid, binary nature that makes them so incredibly powerful for decision-making. To put that into perspective, think about how this maps to our reality. In the real world, think of a physical light bulb switch. It's either on or it's off. There's no in-between. Well, unless you're a kid trying to balance the switch perfectly in the middle, but we'll just ignore that. Or think about a website asking, hey, do you want to receive our marketing emails? You click yes or no. Now, in the Python world, we don't use on and off or yes and no. We simply use true and false. If a user is logged in, that's true. If the road is closed, that might be false. Python only understands the world through these two absolute lenses. Moving right along to section 2, Python comparison operators. Now, you might be wondering, how do we actually get those true or false answers in our code? How does Python evaluate a situation to give us a Boolean in the first place? To really get this, let's use this fantastic mental model from our source material. Imagine a virtual guard standing at the entrance of a roller coaster. This ride has a very strict rule. You absolutely must be 18 or older to ride. When you walk up and say, hey, my age is 14, the guard compares your age to that rule. The guard does a quick mental check and says, nope, no way, you can't ride. Well, comparison operators are exactly the mathematical tools that our virtual Python guard uses to check those conditions. So let's look at the actual tools in our virtual guards toolkit. We've got the double equal sign for equal to. We have the exclamation mark and equals for not equal to, and then, of course, your familiar math symbols. Greater than, greater than or equal to, and less than or equal to. When Python reads these symbols between two values, it evaluates the whole statement and returns one of our trusty Booleans, true or false. Okay, let's pause for a quick interactive check. Put your Python hat on for a second. If you feed Python this exact statement, 90 is greater than or equal to 5. What is Python going to return? Think about the logic there. Is that statement correct? True. Absolutely. You got it. Python reads the statement, says, yes, 90 is indeed greater than 5, and hands you back a true Boolean. It's completely logical, mathematically sound, and super straightforward. Now here is a really crucial point. Actually, this is a golden rule highlighted by the instructors to save absolute beginners literally hours of frustration. It's all about the difference between equal signs. A single equal sign assigns a value, like telling the computer my age is 18. But a double equal sign, that asks a question. It compares them, asking, is my age exactly equal to 18? Mixing these two up is one of the most common early coding mistakes, so for sure keep this rule in mind. Which brings us to section 3, making decisions, if and else. Okay, so we've got our Booleans, and we've got our operators to create those Booleans. Now we combine these tools to actually make our code think and react. Let's look at this sequential logic of our roller coaster program. This shows exactly how the guard's decision maps into Python's syntax. Step 1, the program takes the user's age as an input. Step 2, it compares that input with the age limit of 18. And step 3, based on whether that comparison yields a true or false, it prints a very specific result to the screen. To actually make this work in code, we use an if statement. But there's a huge, vital syntax rule in Python here. Think of an if block's indentation kind of like a door lock. When you write an if statement, the code that follows it must be indented with spaces. If those spaces are missing, the door won't open and your code will instantly break and throw an error. Python is incredibly strict about this spatial awareness because it's exactly how it tells the computer which actions belong inside which decisions. And this flow perfectly lays out why that matters. On one side, if the condition is true, meaning the person is 18 or older, the if block triggers and Python prints, "You are allowed." But what if they're only 14? The condition is false. Without an else block, the code would just silently do nothing. It would just sit there. The else statement is our fallback safety net. It ensures the code always knows what to do, no matter what. If that first condition is false, the else block automatically catches it and prints, "You are not allowed." All right, section 4, advanced logic, and/or. So as we all know, real-world decisions are rarely based on just one single factor, right? Imagine our roller coaster guard gets a brand new safety memo for management. Now, they don't just need to check your age, they need to check your age and your weight to ensure you can safely ride. Suddenly, we need a way to check multiple conditions simultaneously in our code. And for this, we use logical operators, primarily and/or. Their rules basically dictate how strict we want to be. With and, both conditions absolutely must be true. If you're old enough but your weight is below the safety limit, the whole statement becomes false. The instructors actually liken this to a blood donation scenario. You must be the right age and not underweight, otherwise you're turned away. On the flip side, the or operator is much more flexible. Only one condition needs to be true for the whole statement to pass. Combining these two gives our Python guard incredible, nuanced intelligence. Finally, section 5, the developer journey. We have covered a lot of technical syntax today, but let's take a second to talk about the mindset required to master this. During the live class that sourced this material, a poll revealed that 58% of the audience were complete beginners, 33% were mid-level, and only 9% considered themselves pros. So if you are struggling to grasp these logic concepts right out of the gate, look at that massive 58% slice. You are in very, very good company. That initial struggle, it's a completely normal, actually necessary part of the beginner phase. The instructors also provided some absolutely crucial non-coding advice that's vital for your overall success. First off, don't give up on the logic building phase. It takes time for your brain to literally rewire itself to think like a computer. Second, technical skills have to be paired with consistency. Commit to daily self-learning and practice. And finally, you have to market yourself. Build a professional brand on platforms like LinkedIn. Even the most brilliant developers in the world won't get hired if no one in the professional world knows they exist. So, this leaves us with one final pretty empowering thought to chew on. Are you ready? Are you ready to write your first logical condition, build your own virtual roller coaster guard, and start establishing your developer brand today? The logic is quite literally in your hands now. What will your first program decide? Go open up your code editor, start practicing those if and else statements, and I will catch you in the next explainer.